Hello students, in today's session of NCERT Chapter Thermodynamics +1 Physics, very basics on the topic of heat engine, refrigerators, Zeroth and Second Law of Thermodynamics will be cleared through illustrations. In earlier session, we have gone through regarding first law of thermodynamics and its application, which you can review on YouTube channel Sethi Learn. In today's session, we are going to discuss efficiency of Carnot engine, coefficient of performance, relation between them, Zeroth law of thermodynamics, second law of thermodynamics, all points being very important for 11th standard, JEE, NEET, CUET, and other entrance examinations. It is requested, please go through the complete session. Now, let's start with the concept and questions. Question is, explain different cycles of Carnot engine or obtained expression for efficiency. What is Carnot engine? It is an ideal reversible heat engine which operates between two temperatures, source and sink. Source is temperature T1, sink temperature is T2, is known as a Carnot heat engine. Operating temperatures are T1 and T2. The designed engine is a theoretical engine which is free from all defects of a practical engine. This engine cannot be realized in actual practice. However, this can be taken as standard against which the performance of an actual engine can be judged. Parts of the Carnot engine. What is source? Having infinite capacity. How much heat is taken from this? Temperature does not change. This is the sink. How much heat is reacted to this? Temperature does not change. This is the working substance. Working substance is ideal gas. This is the cylinder. Right? Carnot cycle. As the engine works, the working substance of the engine undergoes a cycle known as a Carnot cycle. It consists of the following four strokes. It consists of the four strokes. What are the four strokes? First stroke, isothermal expansion. This is isothermal expansion, A to B. Isothermal means temperature is kept constant. The cylinder containing 1 mole of ideal gas as working substance allowed to expand slowly at constant temperature T1 by putting it on the source. जो सिलेंडर है उसको सोर्स पे पुट किया, एक्सपेंशन विल बी देयर, टेम्परेचर विल रिमेन T1. This is isothermal, right? Then second stroke, adiabatic expansion. Adiabatic expansion is curve BC. What happens in adiabatic? The cylinder is then placed on the non-conductive stand and gas is allowed to expand adiabatically till the temperature falls to T1 to T2. Now, to calculate work done in both the processes, this is the isothermal expansion, this is the adiabatic expansion. Work done isothermal. W1, that heat absorbed by the system. Q1, that V1 to V2. Volume changes from V1 to V2. Volume changes from V1 to V2. Then RT1, we have taken n equal to 1 mole. RT1 log V2 upon V1, Vf upon Va. That is area of ABGEA. This is one work done. Then work done in the second one. That is V2 to V3. This is V2, this is V3. V2 to V3. That is PdV. Finally, answer is R upon NR hota na. N is 1 mole. Gamma minus 1. Gamma is the specific heat ratio. Specific heat ratio. T1 minus T2. That is area of the curve. a BCHG, BCHG, this one area, right? Now, second stroke, now to move third stroke. Third stroke is isothermal compression and fourth stroke is adiabatic compression. In both the strokes, we will find the work done. Curve CD. The cylinder is placed on the sink and the gas is compressed at constant temperature T2. Compressed at temperature T2. Work done equal to heat released by the system. W3. Third stroke W3. That is V3 to V4. PdV. So log final volume upon initial volume. Volume is decreasing, therefore, in this case, compression volume is decreasing, so negative work. V4 upon V3, that is area, right? This is one expression. Fourth expression is, fourth stroke is adiabatic compression, curve dA. Curve dA. This is curve dA. Area will be this one. In this case, P4, V4, T2, P1, V1, T1. So in this case, work done will be minus V1 to V4 initial, this is final. PdV R gamma 1 T2 minus T1. This comes out to be this one. Means W1 is known, W2 is known, W3 is known, W4 is known. Right? Now, efficiency of Carnot engine. What is that? Work done divided by heat input. Work done by the heat input. Net work done क्या होगा? There were 4 strokes. First, isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. 4 works are there. In this case, these are the expansion, these are the compression. So net work is, this comes out to be equal to this one. So this comes out to this. This is the area ABCDA. 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 This is the work done. Right? Now, efficiency is this one. Finally, this one. This comes out to be Q1 minus Q2 upon Q1. That comes out to be 1 minus Q2 over Q1. Values put कर दी हमने. Now, as during adiabatic expansion and adiabatic compression, we use the relation TV gamma equal to constant. If we use this relation in both the cases, we get since point B and C lie on the same derivative T1 V2 T2 V3, we get this relation. And also similar point D and A lie on the same derivative term. D and A, this and A lie on the same derivative term. So using this relation, we get this one. This is equation 2, right? From these two, we get this thing. Now, substituting on this, we get efficiency as 1 minus T2 over T1. These terms will be cancelled out on substituting the above. These terms will be cancelled out. Efficiency of engine is 1 minus T2 over T1. Basic formula is, what is the amount of heat is given to you? Q1 equal to W plus Q2. This is the basic formula. And efficiency is defined as what certain points regarding the efficiency of Carnot engine. Depends only on the temperature of the source and sink. Efficient Carnot engine does not depend on the nature of the working substance. Next, efficient Carnot engine will be 100% if the temperature of sink is 0 K. As practically we cannot run a sink at 0 K Kelvin, so it is not possible to have 100% efficiency. Right? Now, next question. Question is, Carnot Engine takes 1000 kilocalorie of heat from a reservoir at 827 degrees centigrade and exhausts it to 6 at 27 degrees centigrade. How much work does it perform? What is the efficiency of the engine? We have to find two parameters, W, this one, and efficiency. Concept, applicability, and solution. One is source at temperature T1. This is given to you 827, 820, that is absolute, plus 273. This comes out to 1100 K. This is T1. And T2, 27. 27 plus 273, 300. This is T2. T1 is not T2 now. We have to find out this one. From this, we observe that Q1 is equal to W plus Q2. So W will be equal to Q1 minus Q2. Q1 is given to you 1000 into 10 to the power 3 calorie. If Q2 is known, W is known. We know the formula, efficiency equal to net work done divided by the heat input, that is Q1, that is W by Q1, that is Q1 minus Q2 upon Q1, that is 1 minus Q2 upon Q1, also 1 minus Q2 over T1. These are all the formulas for efficiency. Now, as T1 over T2 equal to Q1 over Q2, so Q2 will be equal to T2 over T1 into Q2 will be T2 over T1 upon to Q1. इसको सिंप्लीफाई कर लेंगे, that is 1300 divided by 1100 into this comes out to 10 to the power 6 calories. Now, therefore, W will be equal to Q1 minus Q2. Both are known. On simplification, we get answer is 7.25 into 10 to the power 5 calorie. This is the answer, right? Further, efficiency is 1 minus T2 over T1. T2 is 300 divided by 1100. This comes out to be 1 minus 3 by 11 into 100, that is 8 by 11 into 100. This comes out to be 72.72%. This is all about the efficiency and work done, right? Next question.
Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE Main, JEE Advanced, NEET, CUET, and other entrance examinations. These concept clearing videos are very, very helpful and useful, which you can review on YouTube channel Sethi. In addition to this, I would like to say that these papers, complete video of sessions are available on Sethi YouTube channel, which you can review on Sethi. In addition to this, further, these papers, detailed solution with additional information available on website setyswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल सेठी स्विफ्ट लर्न सब्सक्राइब नहीं किया, Please subscribe it and share with your colleagues and friends. Now let's start with the question.
Question is, in a refrigerator, heat from inside at 277 Kelvin is transferred to a room at 300 Kelvin. How much joules of heat shall be delivered to the room for each joule of electrical energy consumed ideally? Concept, applicable, and solution. What is a refrigerator? It is an apparatus which takes heat from a cold body, that is inside refrigerator. Inside refrigerator in this case. Work is done on it. Work is done by compressor. Work is done by, and the work done together with the heat is rejected to the source. Rejected to the source means room. T1 is, this is 277 K, that is 4 degrees centigrade inside the refrigerator. Inside refrigerator. This is room where heat is rejected. This is 300 K, that is 27 degrees centigrade. Each joule of work, that is 1 joule of work, right? T2. Now, in this case, Q2 plus W equal to Q1. This will be applicable also here, right? What is the coefficient of performance? It is defined as the quantity, ratio of quantity of heat removed per cycle to the work done on the working substance per cycle to remove this heat. It is denoted by beta equal to Q2 upon W, that is Q2 upon Q1 minus Q2, that is T2 upon T1 minus T2. Now using this, Q2 upon W equal to T1 minus T1 minus T2. As we have to find the Q1. Q1 is equal to W upon Q2. 1 joule ये है प्लस Q2 हम यहाँ से निकाल देंगे. तो Q2 की वैल्यू will be equal to 1 upon T1. T1 is 300 upon 300 minus 277. On simplification, Q2 comes out to be approximately 12 joule. Right? Now this substituting here, so Q1 comes out to 1 plus 12, that is 13 joule. This much amount of heat will be rejected to the room. This is the answer. Right? Next question. Question is, state second law of thermodynamics. Second law of thermodynamics. The first law of thermodynamics is the principle of conservation of energy. Common experience shows that there are many conceivable processes that are perfectly allowed by the first law and yet are never observed. Example is, nobody has ever seen a heat transfer from a cold body to a hot body by itself. But such a thing would be possible if the principle of conservation of energy were the only restriction. Thus, the second law of thermodynamics is a general principle which places constraints upon the direction of and the attainable efficiency of or coefficient of performance. It also imposes restriction on the entropy. Definition in terms of entropy. What is entropy? Entropy in loose terms is a measure of amount of disorder within the system. Statement according to second law of thermodynamics, entropy of an isolated system will always tend to stay the same or increase, or in other words, energy in the universe is moving gradually towards disorder. Second statement, Kelvin's Planck statement. No process is possible whose sole result is the absorption of heat from a reservoir and the complete conversion of heat into work. That is not possible. Means that in heat engine cycle, some heat is always rejected to the low temperature reservoir, right? Another statement is closest statement says that transfer of heat from low temperature to high temperature reservoir, some external work should be done on the cycle. This is applicable all refrigerators, heat pumps, air conditioners, right? Next question. Question is state Zeroth law of thermodynamics. Zeroth law of thermodynamics is equivalent to transitive property. Transitive property in mass. If A are B and B are C, then A are C. This is the transitive property. Exactly in this case, if two systems A and B are respectively separately in thermal equilibrium with the third system C, then A and B are in thermal equilibrium with each other. That is, A and C, B and C are in thermal equilibrium. Means temperature of A and temperature of C is equal. Similarly, temperature of B and temperature of C equal. If this is the case and they are in contact, then temperature of A will be equal to temperature of B. This is the Zeroth law of thermodynamics, right? Now, I would like to request, if you are new to my YouTube channel, Sethi Learns, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.